Foundation, Video 4, Design. We now want to make a calculation and select Calculate and then Analysis and Design. We receive an informational message that the plate theoretically lifts, meaning that the whole plate no longer is effective. This is by no means the limit of the capacity and should only be regarded as pure information. The next message, however, shows that the calculation not has been possible to perform. The punching capacity is insufficient with regard to reinforcement diameter 6 mm situated in one layer, although this has been placed as close as was previously allowed. We will then increase the allowed diameter under input reinforcement to diameter 20. We now get a result where the reinforcement has been concentrated in the area under the column. We study the results and shows result ground pressure check. We see that the current ground pressure is lower than the allowable with respect to the effective area, which for load case 1 is 3.76 meter multiplied with 8 meter. This can also be studied graphically with the tool Uniformly Distributed Ground Pressure. We now see the results for load case 1, where the ground pressure is 71.6 kN per square meter on the effective surface case. If one wants to study a different load case instead, choose View Load Case. And then the desired load case, for example, load case 2 is shown. The next interesting result is the slide capacity under slide check. And we see that it is satisfactory for both the ultimate load cases. Moments are presented at the column for 4 sides and are calculated with respect to a triangular ground pressure, which can be studied with the tool Navier stress distribution. For load case 1, we see that the entire plate is not effective and the moment to the left of the column is negative, which means that top reinforcement will be required. Current shear forces are calculated at the section prescribed in the code. Required bending reinforcement is shown in tabular form, where the program has selected diameter 12 mm with regard to bending. Reinforcement in the X direction is the primary reinforcement, meaning it is located nearest the bottom edge of the plate. With the toolbar bottom reinforcement. This reinforcement is also shown graphically as seen before, and we see that it's increased in the area under the column. With the toolbar top reinforcement, required top reinforcement is shown. Under shear check, it is shown that the capacity with regard to shear is sufficient. And under crack widths, we see that the maximum crack width for the SLS load case is 0.35 millimeters.